You guys know that it is divided into the somatic and the autonomic nervous system. So that's just two divisions. They're doing two completely different things. And we're going to be talking about both of those divisions in detail. Before we do, though, some generalities. We're going to draw the big picture of things. So we're going to take these words here, and we're going to draw this picture, except the way we're going to draw it, I think is going to make it a bit more clear. At least in my eyes, it's going to. So let's draw the peripheral nervous system. In order to draw the peripheral nervous system, we still have to include the central nervous system. You guys are well aware that the central nervous system is talking through the peripheral nervous system, that the peripheral nervous system is talking to the central nervous system. So it's vital to have it in this picture. So we're going to put it right at the top. And so the central nervous system, as you guys know, is made up of the brain and the spinal cord. So we're going to put the words brain and spinal cord right at the top of the page. And we'll label it over here to the right. That's the central nervous system. You guys will know that. And so now let's draw the peripheral nervous system and what it's made up of. It's made up of some receptors. Now these receptors here are the same receptors that we discussed at the beginning of this semester. So it was the second chapter that we did. Remember that we skipped most of that chapter? There was what, about maybe 7, 8 lines that we went over in that chapter? So if you go to the beginning of the notes where it talks about receptors, those are the receptors I'm talking about now. All right? These receptors have a job, and their job is to gather stimuli. Now, when it comes to stimuli, what do I mean by that? Stimuli is plural for stimulus, so many different kinds of stimuli. That stimuli could be the voice, or the sound of my voice. It could be pressure, it could be pain, it could be blood pressure, it could be pH levels in your body, it could be osmolality. Those things are being detected by receptors on your skin, in your muscles, in your stomach, in your blood vessels, all over the place. So we're going to talk about those in a lot of detail actually today. All right? Those receptors are gathering things. And then they're going to deliver whatever that stimulus is, whatever the information is from that stimulus to the central nervous system. So now we're going to draw a line here, and I'm going to put little chicken feet there, and then I'm going to put little dots here. What do you think the dots are? Neurotransmitters. What neurotransmitters? You name it. There's about 60 or 70 different ones. We learned about a dozen. Substance P. That would be one example. Serotonin, whatever. Some neurotransmitter. So it's delivering information to the central nervous system, either the brainstem or the spinal cord. That would therefore obviously be an axon, right? What kind of an axon? Starts with an S. That takes information to the central nervous system. Make lecture Cedar proud. Sensory, correct? So that would be an axon from a sensory nerve. A nerve is a bunch of axons, right? That's basically what a nerve is. So we have a sensory axon there. I'm just drawing one, but I could have drawn many and made it a nerve. How's the information getting there? Is it magic? Actually, it kind of is. What are these things? Those are action potentials. Most sensory nerves, by the way, are myelinated. We don't have to really put them in there. That's anatomy. But we do have to understand that those receptors that are gathering this stimuli need to take the information from the stimuli and talk to the central nervous system. Action potentials are what? Information. That's the information. That's how it's getting there. We're going to cause the release of some neurotransmitter, and now the central nervous system is going to be aware of whatever that stimulus is. All right? So far, so good. The central nervous system can also go in the other direction and talk via the peripheral nervous system to things called effectors. And when we're talking to the effectors, when we're causing something to occur with the effectors, what's going to happen as a result is we're going to get what we call an appropriate output. Now, when I talk about an appropriate output, what might that be? Things we'll discuss in more detail later, but I'll give you a few examples now. Contraction of a muscle, release of hormone from a gland, increase or decrease in blood pressure, increase or decrease in osmolality, whatever. Something is going to happen via that particular, oh, and by the way, let's put little dots here. Those dots are neurotransmitters. So given that we have the central nervous system extending out to these effectors, what does that line represent? Not a sensory neuron, but a what? Motor. So that's motor output. We have sensory input to the central nervous system. We have motor output from the central nervous system. All right, you guys might have called them afferents and efferents, maybe. Sensory is afferent, motor is efferent. How does the information get to the effector? Action potentials. So the peripheral nervous system are those motor and sensory nerves plus the effectors and the receptors. There's your peripheral nervous system. And that's what we get to talk about for 3 lectures. The peripheral nervous system. We're going to include the central nervous system. We have to, but the bulk of the discussion is going to be on what I have outlined there, peripheral nervous system. All right? So right there is our big picture. That's what we're going to study for the next 3 lectures, right there. So when it comes to this picture right here, is that picture right there. I just think that's a bit more clear, at least in my eyes it is. Are we good? We're going to start with one side of the story first, though. We're going to start with the right side of the story. So what we're going to start with is this. We're going to talk about the sensory side of things. We're going to start with the sensory side of things by talking about the receptors first. So the first thing we're going to do is talk about these receptors. Now, when it comes to the peripheral nervous system, and I know you guys know this, but let's just write it down so that we're completely engrossed in what we're doing here. The peripheral nervous system, there are 2 divisions, as you guys know. One is the somatic, and 2 is the autonomic. And then the autonomic has 3 subdivisions, although you guys probably only learned 2, that's okay, because we're only going to talk about 2 of them. We have sympathetic, we have parasympathetic, and then we have a third, which is not often talked about, and we're not going to talk about it yet this semester, we're going to talk about it next semester. That's the nervous system of the digestives. It has its own little nervous system, the digestive system does. So we're only going to be worried about these 2, all right, which are part of the autonomics. So when it comes to your peripheral nervous system, when it comes to all this stuff that we just drew, it's either somatic or autonomic. It's either somatic, parasympathetic, or sympathetic. That's what it is. And they do different things, and they control different things. We're going to be talking about exactly what they control, what influences them, in a ton of detail. It's going to take us 3 lectures. Okay? 225 minutes is what it's going to take us to go over this. And it's not even enough time, but we'll still get it all done. Okay? Are we good? So, what we're going to again deal with are these receptors. So there are receptors, there are receptors that are somatic receptors. There are receptors that are autonomic receptors. They work the same way, they just detect different stuff. All right? Their stimuli are different, and so we're going to talk about that. So let's talk about these receptors first. There are somatic receptors, once again, and there are autonomic receptors. Again, the job is to gather stimuli and send that information to the central nervous system to be interpreted. That's what this is. I just said what that is right there. All right? So, we have somatic receptors, and we have autonomic receptors. What's the difference? Number 1, where they are, and number 2, the stimuli that stimulates them. So let's talk about them individually. A somatic receptor is either an exteroreceptor or a proprioreceptor. The exteroreceptors are located in the skin. The proprioreceptors are located in muscles and joints. Okay, we're just going to keep it simple like that. Now, I have a line here, although they can influence the autonomics, although they can influence the somatics, I'm not too terribly concerned about that. But I just kind of wanted to make it clear to you guys that there's a little crosstalk between the 2 divisions of the peripheral nervous system. But we're just going to kind of keep them separate just to keep it more clear. okay? And I'll give you one example where there's crosstalk, but I'll just do it later. For right now, this is what I want you to know. Somatic receptors are located here, and these are the two different kinds, all right? And we already talked about stereoreceptors. Not in a lot of detail, but we've already talked about it. And I'm going to show you a picture to remind you. You remember that picture? Pacinian corpuscle, Merkel's disc, Meissner's corpuscle, free nerve endings. Those are stereoreceptors. Those are obviously located in the skin. So what I have here is a picture of the skin with all these different receptors. And at the time you first saw this, all I needed you to know is what their job was: to detect pressure, pain, tickle, itch, heat, cold, whatever. That was their job. Now I'm going to show you how they work. Okay? So what do I need you to know? That stereoreceptors, okay, we learned about almost all of them here in the skin, are somatic receptors. Okay? And their job is to gather certain stimuli. What's the stimulus to a Pacinian corpuscle or Meissner's corpuscle? Pressure. That's the stimulus. What's the stimulus to a pain receptor? Pain. What's the stimulus to, and that would be a free nerve ending, right? Free nerve endings do all kinds of different things. There are pain free nerve endings, there are heat free nerve endings, there are cold free nerve endings, ones that cause you to feel tickle and itch. That's the stimulus. All right? What else? The other kinds of somatic receptors, and there are two: exteroreceptors, proprioreceptors. The proprioreceptors are the ones in your muscles and your joints. And you're going to be learning about these in detail with Lecturer Sieber. Golgi tendon organ is an example. Muscle spindle is an example. Those lie within your muscles. They lie within your joints. What stimulates them? Stretch, for example, is what will stimulate these. Stretch of the muscle will stimulate these. You kind of walking, they help orient you. If you're walking, I don't know, down the hall or down outside and the sidewalk is kind of raised, you don't notice it, you kind of trip over it, but you don't fall down, and you kind of catch yourself, your proprioreceptors detect that that's happening and stop you from falling. It allows you to catch yourself. Proprioreceptors allow you to walk properly. They're always detecting what's going on when your muscles and your joints are moving. That's their job. So what's stimulating them? The stretch of the muscle as you're working, for example. All right? They're located someplace else, but they're still part of the somatic nervous system, as are these stereoreceptors. The stimulus is different, but they're still going to work the same way that I showed you. Then we have the autonomic receptors. These are receptors of the autonomic nervous system, the other division of the peripheral nervous system. They're detecting completely different things, and they're located in completely different places. Autonomic receptors, otherwise known as visceral receptors, do not detect heat in your environment or pressure in your environment. They're not detecting stretch in a muscle because that's not their job, and that's not where they're located. These particular receptors are located in the viscera, your organs. They're located in blood vessels, they're located in your heart, they're located in your stomach, they're located in your bladder. They're located in the organs of your body. So the somatic receptors are detecting things in the outside environment, the world that you live in. These visceral receptors, it's your internal environment. They're detecting pH in your stomach. They're detecting pH in your blood. They're determining what osmolality is in your blood, in your interstitial fluid, inside of your cells. It's detecting the levels of oxygen, carbon dioxide. All of the things that are going on inside of you, that's what these receptors are detecting. That's their stimulus, or stimuli, I should say. Yes, sir?
Did you say pressure wasn't under autonomic?
Pressure is under autonomic, it's just not the pressure in the environment. Blood pressure would be the pressure of the autonomic nervous system. So there are receptors within the heart, for example, within big blood vessels that detect pressure within blood vessels. So pressure is part of both, but it's pressure coming from two completely different places. This kind of pressure, that's exteroreceptors. Blood pressure, that's visceral receptors. All right, and they have special names, and we're going to go back to these names when we get to the very end of this chapter. Okay, we're going to come right back to this particular page, on the last page. We're going to put everything together. Okay? Now, it doesn't matter if it's a somatic receptor or an autonomic receptor. The way they work is exactly the same. How does a receptor